and they have different connections between them, so that's why they are like compressing and they are relaxing in different manner. Yeah, and so that's why we can see them in different colors. So this is, I like, there are Russian, but I like this picture, and you can figure out, you see, this is for air, this is how these waves, this ramification looks in air, so this is how they look in bone, and this is how they look in soft tissues, and they're different. Yeah, we can figure out this, so this is very, very good. Okay? And so that many, many interactions.
What is this?
This is a picture from one Russian student from last year. I like it. I just a little bit adjusted it. Yeah, so this is about that what we study and what we take into account in ultrasound. Yeah. Acoustic density or acoustic properties, how do you like it? This is their official things, like sound speed, like this thing. Yeah. Or it could be expressed in sound impedance, but it's kind of more difficult. Two parts, yeah, which are inside this definition, acoustic density, or inside this thing. Yeah, so this is two different tissues, structures, areas, medium 1 and medium 2. Pay attention that for ultrasound specialists the differences matter. Yeah, but if it is one tissue with more acoustic density, is it closer or further? That doesn't matter. The difference matter. Yeah. So yeah. Anyway, we have a boundary. We can have many different processes. First of all, reflection, and then deflection, and then a little bit of absorption,
then scattering.
A bit of scattering in case of ultrasound. A big degree of scattering. Yeah? So what's happened on this, that this thing, yeah, reflection is useful, especially if you have situation something like this or this, yeah, then the boundary is even big like a line, yeah, and then the beam, yeah, is like 90 degree to this beam, perpendicular to this beam, yeah, and if the boundary is like this, or the degree will be like this, so we'll have also artifacts, yeah, something like false pictures. And absorption, reflection, yeah, we borrowed it. This is from nature, yeah, you know that bats and dolphins, yeah, they're using these to find structures in hunting, yeah, also. So they are sending ultrasound and getting this reflection back, so that's what's going on, yeah. And if we look at the ultrasound transducer and our structure somewhere deep inside the body, it's exactly the same. Sending and receiving. What is the difference? But they usually want to have a picture of some part of the body. So our transducer is sending not one pencil beam ultrasound, yeah, but kind of real beam. So, and we have different ultrasound beams, and they are going through several structures, several boundaries, and that's why we have a picture, yeah, and not just some signal, yeah. So this is just for one signal. For example, you can have this idea also, yeah. This is what they use in trying to figure out how deep the ocean is, yeah. So it's the same idea. It's also echolocation, but in this situation we'll have just one, echo, and we'll analyze this. And ultrasound specialists, they analyze many echoes, yeah. This eye, so let's figure out how it's going on. So this is the beginning of the study. This is the surface. And in this case, in case of eyeball with hemorrhage, we see that something is swimming, yeah. So there is water and some soft tissue. So this is how it's going on, yeah. So this is this idea of echolocation. We are locating each descriptive terms and colors in ultrasound. So if we are studying echoes, so the basic definition, the basic term will be echogenicity. What is echogenicity? The ability to be the source or to produce echo, yeah. And yeah, since ultrasound is only positive technique, the bigger the echo, yeah, the whiter the signal. And so let's try to figure out what can we see and what color will what mean, what color does it mean, yeah? So first of all, water. What is water? Non-reflective tissue. It's non-reflective. Sometimes the name is, it's echolucent tissue. It's similar to air in X-ray. Yeah? It just the echo is going anechoic. Like so, every time when you see something completely black, that means you see water. Anyways, boundaries between C and A, C and bottom or bottom, this bone, yeah. So they are walls. They are walls, yeah. So they are eco-opaque, yeah, like this, yeah. And so what do they have? Completely reflected, yeah, and so we'll have white color, and we'll say hyperechoic, and then structures, and then structures. They are hyperechoic. Keep this in mind, this, yeah, and partly not, and so that means that they will be gray, yeah, and in general they say with average echogenicity, yeah. Well, but actually this is about air, this is about soft tissues. Well, let's have something new. So this is the same we've discussed already, but if to add, yeah, what specialists are describing echogenicity in reality. This is just classification, yeah, but in reality, yeah, how it's going on. Let's try to figure it out, yeah. It's just their impression, how do they see them? So they're comparing colors and they say, okay, this is less or the same or a little bit more gray than surrounding or something like this. Do you think it's a good way to assess tissue characteristics for water? And so this is cyst. This is a cyst. And what do we see in this slope? Something in white and with these dark part behind.
reflecting.
So this is typical for dense structures, and this is calcification.
Shadow. It's
And
like
what do they
moon.
see in this slope? Something which is gray but darker. Great. So we'll say it's
Hypoechoic.
yeah. And what do they see there? This is the lobe, and this is something almost the same color like the surroundings, and we'll say isoechoic. And yeah, this is both of this is highly suspicious of tumors, yeah, because yeah, they are not white but they are gray. This is kidney capsule and this is cortex, yeah, and this is the middle part, yeah, where this is the fat in the renal pelvis, and they are going one by one because this is like ultrasound. It's just passing through, yeah. And so in this situation, we also have to think about, are they the right color? Are they the right echogenicity? And how can we do it? Comparing this organ and that organ, yeah. And in this situation, yeah, we can say that usually in norm, yeah, liver is less echogenic, yeah, comparing with the kidney. And see this picture, here it is, yeah. So this is spleen and liver, and this situation, yeah, we see like spleen should be the same color like kidney, yeah. And this is how it works in ultrasound. So they have to keep this in mind, to compare, to have experience, to understand that basically the colors should be like this. So this is kind of really interesting, really special. Yeah, and it is a fibrous structure, and so that's why it's just white. Yeah.